this exercise. This exercise are based on these four relations, and these four relations already introduced in exercise 2.3.1. Okay, now let's record these four relations. Product U is used to store the information of all products, including PC, laptop, and printer. Maker, in the information of product in the information of product includes makers, model of the product, and the type. The type is PC, laptop, or printer. And the other information of PC are installed in is installed in PC, including model of the PC, speed of the PC, RAM of the PC, HD of the PC, and the price of the PC. And the model information, speed, RAM, HD, screen price of laptop. All this information is stored in laptop. And the model, color, type, price, this information of printer is installed in printer. And the color is blue. True means it's color printer, and false means it's a black-white printer. Okay. And the type is the type of printer, such as laser. Okay, and we also and some sample data has already showed. Now, in this exercise, we'll write expressions of relational algebra to answer some queries. Note that in this exercise, the result of the expression needn't to be written in your answer, and some of you giving me the result. I don't know why. Okay, let's look at these queries. Firstly, what PC models have a speed of at least 3? Okay, speed of PC. We can find this information from the relation PC. PC model in this relation. The speed of PC is also in the PC. So all the models and the speed of PCs already stored in PC. We can use PC to write the expression. Okay, and from this query, we know speed is at least 3 is the condition. If we want express the condition to filter, if we want to filter a relation with some condition, we'll use selection. So we write selection sigma. Then the condition is speed at least, so larger than or equal to at least. Okay, PC. So we'll find the tuples from PC with speed at least 3. And then we just need models. So we'll use projection to filter the attributes. Model. Okay, model. Okay. Now from this, Okay, use this expression, we can find the PC models have a speed of at least 3. Okay, the next one. Which manufacturers make laptop with a hard disk of at least 100 GB? Manufacturers. All information of manufacturer is in product, and HD information of laptop is in laptop. So we'll use these two relations to finish our expression. Okay, now firstly, if we want to do this query, answer this query, firstly answer the query of the model of the laptop model with a hard disk of at least 100 GB. And we can write the expression like this. This is a condition. This is a condition. So we'll use selection HD at least larger than or equal to 100. Okay, this is the information in laptop. So laptop is the operand. And now we can, from this expression, we can find all the information of laptops with HD of at least 100 GB. But now we'll get makers. So we are union product with result of this expression. Union it. Okay. Union. There are 3 ways to union two relations: cross join, national join, or theta join. Which one? Which one will be where we will use or where we use? And in here, between there is only one attribute with same name in product and laptop, and we want to. In fact, we want to we want to join product and laptop with model. Model is the only attribute with same name, and we want to join it with this model. So we can use national join here. Product, join product, and this result. Okay, now, but we don't know all, but we don't need all the information. We just need the makers. So, yeah. So, we use high project maker. High project maker. Okay, this is the B. Now C. C is a little difficult because in the C we want to find the model number and price of all products. All products made by B. All products include PC, laptop, and printer. And now we'll find. It means that we'll find the model and the price of PC, laptop, and printer. made by B. Here we can use union. I think if this question if this in this query we change the if we change the query like this, find the model number of price of PC made by B. It's easy. And if we change the query like this, find the model number and price of laptop made by PC. It's also very easy. So if we use union, we can find the model price of B made by PC made by B. Union, the model price, the model and the price of laptop made by B. Union, the model number and price of printer made by B. So now we can get the model number and the price of all products. Okay. Now, firstly, let's try to find the model and price of PC made by B. Made by B, maker means maker is B. Maker is B. Now, so the maker is B. This is the condition of topper made by B. Okay. Product. And we need to find the price, and the price, the information of price is in PC, so we're union PC. The union PC because model is the only attribute with same name, and we want to join product and PC based on model, so we can use natural join. And now model and price. So project model price. Okay, now we already get the model number and the price of PC made by B. Now union what? Union the product made by B, natural join laptop. Now we can get the information of the laptop made by B and model price. Now we are filter where we are project model and price. Now here we can find, we already found the model price, model number and price of laptop made by B. Now last one, printer. Okay, maker is B, product. Now in this result we get the product made by B, and now we are joining lab printer. Can we use natural join? Can we use natural join? No. Why? Let's look at these two relations. Model, type. There are two relations with same name. We can find these two attributes. We can find these two attributes. This type is PC, laptop, or printer. It's a type of product. And this type is laser, and so on. It's a type of printer. If we do natural drawing, we'll get nothing. We'll get an empty result because we cannot find a two tuppers with same value on model and same value on type. We cannot find that. We just want to join product and printer by model. So we cannot use natural drawing. We use cross drawing and then selection, or we use theta drawing. Now we can use theta drawing here. If we want to write theta drawing, we'll write the condition. The condition of drawing is a model. Okay, so the product dot model is printer dot model. Printer dot model. Okay. Now we join product and printer, and then production. And here we cannot write model because there are two models in the result, product.model and printer.model. You can choose one. Product.model or printer.model here. Okay, price. Okay, now we get the model number and price of printer made by B. Most of you forget this one. You use natural drawing. No, cannot use natural drawing because we don't need type. We don't need type as the drawing condition here. Okay. Now, this is the C. Okay, now D. Find the model numbers of all color laser printers. Okay, there are two conditions. The first one, color. Color means this color is true. The component is true. Okay, laser. Laser means the type, the component or type is laser. So there are two conditions. We'll write two conditions as subscript or for sigma. Okay, if we write two conditions, we'll use logical AND. Color. Okay, color is true because color is bool, so color means color is true. You can write like this. Well, this one color is true or just color. Okay, color. And the logical AND, we'll write this as a logical AND. Okay, now type laser, so type is laser. Okay, it's the condition. The condition selection on printer. And now we'll get model number, so we use projection. Write the model as the subscript. Okay, it's a D. Now, E. Find those manufacturers that sell laptops but not PCs. Some of you give me this answer. Okay, I write it down. Okay, now product. We know type in product type is PC, laptop, or printer. So we can write the condition of type. Type is laptop and type is not PC. Now product, okay, is a condition of product. And then maker. So some of you give me this answer. Is correct? No. Why? Let's take this for example. Okay, if you write this one, this condition is equivalent with type is laptop. Why? Because when we do selection, we check each tupper, and check, for example, type is laptop and type is not PC. Now we check the component on type. Okay, now type laptop is laptop. Yes, it's true. Laptop is not PC. Yes, it's true. True and true. Now we get true. We'll get true. So B will be select. No, this tupper will be selected. Will be selected. So now that's project maker. So we'll get B. B is one of the result. But let's look at this sample. B sells laptop, yes, and B sells PC. B is not the makers that sell laptops but not PCs. So if you write the expression like this, you get wrong. The answer is wrong. We cannot get the right result. Now, how can I get the right answer? Okay, sell laptops but not PCs. For this but not, we use set operation. Difference. For example, this is the maker. The maker sell PC, selling laptop, and this is the maker sells PC. Okay, we know. Now this part is the makers that sell laptops but not PC. It's the minors. It's the difference. It's the set operation difference. Now let's write the expression by difference. It's wrong, so let's erase it. Okay, now firstly, let's find the manufacturers selling laptop. Okay, now if type is laptop, that means this type laptop, this one, this one, this one, this one, this one, and so on. They all sell laptop. Oh, sorry, not laptop. Product. Product. Maker. Now, we already found the maker selling laptop. And we can also find the maker selling laptop, PC. Okay, now minus. And we can find in this by this expression, we'll find those makers that sell laptops but not PCs. Difference. And know that the operand of difference must have same schema. Maker, okay, is correct. And some of you give me this answer. Type laptop. Product. Type PC. Product. And then projection. It's correct? No. It's valid? Yes. This is valid expression because the product, the schema of this expression is same as the schema of this result. But the answer is not correct. Because, for example, if we type is laptop, we'll get this one. For example, get this one. And by this expression, we can get this one. If we do minus, B1005 PC, B2007 laptop, and this one will be in the result. Will be in the result because this tupper is not the same as this one. So we cannot get the correct result. You can try it by. Okay, find those hard disk sizes that occur in 2 or more PCs. As the example of finding pairs of colleges in same state, which Jennifer said in Stanford MOOC, will use renaming and join. And because the information of hard disk of PC stored in PC, so we'll use PC join PC. Okay, so that PC join PC, and because we know if we join PC, cross-join PC and PC, there are 2 models, 2 speed, 2 RAMs, and so on. So we'll use rename the PC name so that we can distinguish these attributes. And choose HD size occur in 2 or more PCs. It means that when we cross-join PC and PC, we can find the tupples in the result, which P1 dot HD is P2 dot HD and P1 dot model isn't P2 dot model. If we can find a tuple like this, it means that this HD size occur in 2 or more PCs. And then, because we want to find the HD size, so pi P1 or P2 HD. Okay, this is one way. And here, I use cross join and just rename the name of the PC of the relation. And we can also use natural join. If we use natural join, we'll rename the attribute. For example, let's rename the attributes of PC as M1, S1, R1. Okay, HD still be HD. Price 1, the PC. And rename the PC as M2, S2, R2, HD, PR2. Okay, now, in the result of this expression, there is 1 HD, and in the result of this renaming expression, HD is also in the result. So if we use natural join, it means we'll pair the tuples with same component value on HD. So HD. And there is another condition. M model, different model. So M1 isn't M2. Okay, if we can find this tuple, then I HD. Okay. This is another way to answer this question. Okay, this is F. Now G. We'll also use renaming and cross join or natural join. Okay, now here we want get pairs. Get pairs with both the same speed and RAM. So the this is not cross join, it's theta join. Theta join P2. P2 is also rename PC to P2. Okay, and the condition is pairs of models. So as with same speed and same rate, so same speed P1 dot speed is P2 dot speed and P1 dot RAM, same RAM, so P1 dot RAM and P2 dot RAM. And there is another condition. Pairs of PC. One pair should be listed only once, so we can use P1 dot model less than P2 dot model. Okay, you can also use P1 dot model larger than P2 dot dot model. Okay, now we can get the pair I P1 dot model P2 dot model. Okay, this is theta join, and we can also use natural join here. If we use natural join, we can write the expression like this. Okay, row P1, and because we want the same speed and same range, so we'll rename other attributes. M1, speed just as R, H1, P1. Okay, this is PC, natural join, row P2, okay, now M2, S, R, H1, H2, P2, okay, PC. Now, natural join means the tuples with the same value on Rn, on S and R. S is speed, R is RAM, will be paired. And then there is another condition. The condition is M1 less than M2, or you can write it M1 larger than M2, but don't write M1 isn't M2. And then condition projection M1 M2. Okay, this is also an answer for G. Okay, that's all.